Somewhere out there, a star might be dead on the inside, and nobody can tell just by looking. Not extinguished, not exploded, still shining, still enormous, still doing everything a normal star does on the outside. Except buried in its core isn't fire anymore. It's a corpse. Here's how that's even possible. When a massive star runs out of fuel, it collapses in on itself and detonates as a supernova. What's left behind is a neutron star. The crushed leftover core packed so tight that a single teaspoon of it would weigh roughly 1 billion tons. Gravity there is so extreme that if you drop something from just 1 meter up, it would slam into the surface at a significant fraction of the speed of light. It's one of the densest objects in the entire universe that isn't a black hole. Now, put that corpse next to another star. A massive one. A red supergiant, hundreds of times wider than our sun, so bloated and loosely held together that its outer layers barely count as solid. You could practically walk through the edge of one. If you swapped it in for our sun, its surface could stretch out past the orbit of Jupiter. And somewhere inside that impossibly puffed-up shell, there's barely any resistance at all. In crowded regions of space, dense star clusters, or binary systems that go badly wrong, a neutron star can end up drifting too close to a star like that. And when it does, it doesn't just bounce off. It gets swallowed, pulled inside the red supergiant's outer envelope like a stone sinking into fog. Once it's in there, something strange starts happening. Drag from all that stellar gas slows the neutron star down, and it starts spiraling inward, deeper and deeper, straight toward the center. Eventually, it doesn't just sit inside the star. It merges with the core. You'd expect that collision to destroy the star completely. It doesn't. Instead, you get something that looks, from the outside, almost completely ordinary. Same size, same cool, reddish glow, same spot on a star chart. But on the inside, the entire engine has changed. It's no longer nuclear fusion alone holding the thing together. It's a buried neutron star, dragging in material, crushing and heating everything around it to conditions fusion alone could never reach. Physicists Kip Thorne and Żytkow described this exact scenario back in the 1970s. Yes, that Kip Thorne, the one who'd later help discover gravitational waves and consult on Interstellar. The object even carries both their names, a Thorne-Żytkow object, a star wearing another star's face with a dead star's heart hidden inside. For decades, it stayed purely theoretical, a strange idea on paper built entirely from equations. No confirmed example. Nothing you could point a telescope at and say, there, that one's real. So how would you even prove something like this exists if it looks completely normal from the outside? You'd have to catch it lying about its own chemistry. Then in 2014, astronomers found their first real suspect, a red supergiant called HV 2112, sitting in the small Magellanic Cloud, a small galaxy near our own. From the outside, completely unremarkable, but its light told a different story. Buried in its spectrum were unusually high amounts of elements like molybdenum, rubidium, and lithium, signatures that models predicted would only appear if a neutron star's extreme heat was cooking material deep inside a red supergiant and dredging it back up to the surface. It was the closest match to a real Thorne-Żytkow object anyone had ever recorded. Headlines everywhere ran some version of the same story. Astronomers may have found a zombie star, a monster hiding in plain sight this whole time. But here's where it gets messy, and honestly, more interesting. Other teams went back and checked the numbers themselves. Some couldn't replicate every one of those anomalies. One analysis suggested HV 2112 might not even belong to that distant galaxy at all, that it could actually be a much closer, ordinary star sitting in our own galaxy, its strange chemistry explained by a completely different, far less exotic process. The debate never fully settled. Even now, HV 2112 sits in scientific limbo, not confirmed, not ruled out. A second candidate turned up nearby, a star called HV 1417, identified in 2018. And its story just got a new chapter. Using ultra-precise position data from the Gaia Space Telescope, Astronomers recently confirmed it really does belong to that distant galaxy after all. Earlier measurements had simply been too fuzzy to tell for certain. And they found something else hiding in the data. HV 11417 is a runaway. It's moving through space noticeably faster than the stars sitting around it. That detail matters more than it sounds. One predicted fingerprint of a true Thorne-Żytkow object is exactly this kind of motion, getting violently kicked into a new trajectory by the supernova that created the neutron star in the first place. It's not proof on its own. Plenty of ordinary stars turn out to be runaways too, but it's one more piece of a puzzle that keeps almost fitting together. Spectra and star charts might not even be the tool that finally cracks this. And there's a completely different way scientists might finally settle this question for good. If a neutron star buried inside a red supergiant is actively feeding, pulling in material from the star wrapped around it, that process should release a flood of neutrinos, nearly invisible particles that pass straight through entire planets like they aren't even there. Researchers have proposed that giant underground neutrino observatories, built to catch particles from the sun and from distant supernovae, might be sensitive enough to catch that exact signal, even from a star all the way out in the small Magellanic Cloud. And none of this is even permanent. Models suggest a Thorne-Żytkow object can't stay hidden forever. Eventually, the buried neutron star strips away the envelope around it, where the whole system collapses further, possibly into a black hole. It's not a stable disguise, it's a phase. A temporary monster wearing a star costume, mid-transformation. So picture this. Somewhere, possibly right now, a red supergiant is sitting quietly in the night sky, ordinary to every telescope pointed at its surface. And buried at its very center might be the crushed remains of another star entirely, still devouring its host from within. 50 years after the idea was first proposed, we still don't have absolute proof that one exists. Just candidates. Just clues. Just a chemical fingerprint here, an unusual velocity there, and a possible flood of ghost particles nobody has caught yet. Which means the next time you look up at a red star in the night sky, you genuinely cannot be completely sure what's sitting inside it. It might be exactly what it looks like. Or it might be wearing a disguise 50 years of physics still hasn't fully cracked. If this blew your mind, follow for more real space mysteries stranger than fiction, and drop a comment telling me which star theory here sounds the most impossible to you.